We'll now take a look at the OSD core test program. So let's go to Vitus and see it. So what I did in here is I took all this the same exact test we've done before, and in here basically bypass all of the modules, and we wait for about 3 seconds, and then we do the OSD check, which is a function we're going to see the content of shortly. It's currently running, but we're going to see its content. And then here I'm checking basically the very first switch if it's actually asserted. I can basically bypass the OSD using switch 2, which basically makes it disappear from the screen, or I can actually play a little bit with the color, and specifically I can keep the foreground color. The set color function tells me what's the foreground and what's the background. In here I'm telling you the foreground should be, this is basically green. The green is set to 1s, and then the rest basically it's just 1s, or it's like it's the number, the value of switch 9, which is basically either 0 or 1. Technically I'm going to the blue and I'm making its least significant bit either 0 or 1, and the rest are zeros, which is almost all zeros. Like if you set it up to be all zeros, it's going to be chroma key. If it's just 1, that means it's a little bit above the 0, which is black, so it's going to be complete dark gray or effectively black. So let's see the functionality of OSD check, and then we're gonna explore the little one down. So what does OSD check do? Well, OSD does the following. First, it actually sets the color, foreground green, background that dark gray that I just mentioned. It's actually R, G, and B, and this is here just setting the least significant bit of B is 1, and the rest of the bits, including the R and the G, to 0. If I put all of this at 0, it'll just be the chroma key that we've been using, so it'll just basically be a transparent background. So whatever is in the background, or the background color, is just going to pass through. And then I'm making sure that this particular core is not bypassed. I'm clearing the screen, and if you do remember, clearing the screen, all it does is just goes to each one of the tiles and put the null character in it, making it transparent. And then in here, what I'm doing is I'm going through a couple of, like one for loop that going through 64 characters. 64 times 2 is 128. These are basically all the characters I can write, and I'm writing them one at a time. And this is exactly what you see in here. So I have here, which is I, and then I have the 64 plus. So basically, the first row is going to write 0 to 64, and the second one is going to be 65 all the way to 127. Okay, so let's see what's happening in here. OSD, basically I'm going to the right char. So the right char is expecting the X or the Y of the tile. The X and the Y are basically, I'm saying it, okay, so the I goes from 0, but I'm just shifting it by 8. And here is the same, and then the Y is going to be 20, and this is 21, so this is on the next line, and that's what you see. And after each character, we wait for 100 microsecond or millisecond, and then we do these, and then we wait for 3 seconds. So let's take a look at what this test program is doing. I'm going to do a CPU reset in here, and you'll see it's basically I'm disabling all the cores first. I wait for 3 seconds, and then that's the only core that is running. And you see it's 100 milliseconds apart. And what you do see in here is basically that is going from, I'm just going to stop it so that we get to see it. That's going actually from, like, this is 0, 1, 2, 3, 4, 5. It's basically shifted by 8, and this is basically number 7. And then I go and put, this is basically 0, which is the chroma key, because it's a null character. So it's doing exactly what it's doing in the rest in here, which is making it transparent. And then you get to see all the characters in here. Of course, this is what you see of I plus 8. This is the location of this particular one. And that one, it's basically the X of both of them. And then the Y, which is that here, it's 20 in the one on the top, and it's 21 in the one at the bottom. Remember, the Y goes downwards. Okay, and then what am I writing? The first one will be I, which is 0, and the last one should be a 64 in here. Okay, and this one in here is the same. I'm basically writing from 65. So this is what 65, and this is 66, okay? And then all the way there, okay? Or actually it's 64, because 64 plus 0 is 64. So this is actually 64, this is 65, which we know in ASCII, a 65 is a capital A. And you can go to the rest. Okay, so that's how this is actually working. So now the code runs like, and basically runs every character and wait for like 100 milliseconds apart. And of course, this little one in here, which actually stands for, according to the driver, starts to the reverse. What we see is, again, that we define that the foreground character is green, and the background should be basically that dark gray or black. And that's what you see in the first row in here. It's green on black, green on black, green on black. The background is black. As opposed to the one at the bottom in here, it's actually flipped, because it's reversed, which appears as highlighted. So if you set this particular bit value to 0 and you compile and shape it, both lines will be exactly the same. But before I do this, or you can test it actually on your own, it's not that difficult. I want to just show you what's happening in the while loop. So in here, so in the while loop, I have a couple of things that I can do. So first, I'm stuck in the while loop in here. That's because I set my switch here to 0. And then next, what I have is I have a couple of things. I can go to switch number 2, okay, and then I can basically bypass the whole core itself. Like now, all of the layers disappearing based on the value of 2. I'm not going to bypass it. That'll keep that at 2. And now you can go to switch number 9, which is this one in here, and then you can do a couple of things. So let me show you what's happening. So what's happening is I'm setting the color. So the foreground is always green. Remember, the foreground here is actually the characters themselves. The foreground in here is actually the background. Like the green is the background in here because it's reversed, it's colored. So what I'm doing in here, I'm not changing that green at all. What I'm changing is actually the black. So what is the black? Well, the black in here, it's the value of the switch number 9, which is either 0 or 1. And remember, 1 is almost black. So when it is 0, it's actually the chroma key. And that's what you see in here. Because it's a chroma key, it got blended with the background color, which is blue. It's set by the hardware. It's basically the very first thing that's even before the frame buffer. It's just set to blue. And you get to see the blue passing through all the way through these colors in here and the background in here. And you get to see it actually looks like as if it's exactly on the frame or the background color in here. So I'm gonna go and play around with it, and you can see it. Now I'm making it as a 1, which is a little bit higher than that chroma key. It's not the chroma key, so it doesn't get blended. It's not transparent anymore.